Okay. So in the last video we talked about the four basic elements in any simulation system, and of course there are um, many other components that software packages normally have, but you'll always have these four. And let's now talk about variability. Where is the variability coming from? So if there is no variability and you have a deterministic system, then there is no need for simulation. You can simply come up with an algebraic function and solve the function and you will have a solution. But that's not what real systems are about. Real systems are replete with uncertainties, and where are the system variabilities come from? So these are the sources of variabilities. So you have activity time. Okay, so how long does an activity take? And there is uncertainty right there. So service time and repair time, and you need to gather data, figure out what the probability distribution is, like fit the probability distribution. For the data, we looked at fitting probability distributions in at risk. So there are similar um, features in pro model, and then we use that to simulate activity times. Then another source of variability is event arrival. So events arrive, customers arrive, raw materials arrive, parts arrive at various time intervals, and there are some variabilities in time intervals. So we need to gather information about that and machine breakdowns. So machine breakdowns, we had an example of machine breakdown, time between mean time between failures in at risk. So time between failures, so that's an event arrival, the event of a machine breaking down or a system resource breaking down. Okay, so that is an event, and that the arrival time is a source of variability. Okay. Another source of variability is quantities. So if you produce a batch of products, say 100 units, okay, maybe only 95 will pass inspection, or maybe 99 will pass inspection, and things like that. So the order quantity, okay, and then how many, what is the rejection rate from the order quantity, and how much is the order quantity? There may be some uncertainties in that itself. What is the batch size? Okay. And another example of quantity uncertainty is absenteeism. So you have a team of 100, and how many workers will actually show up for a given shift. Yeah. So that's another source of uncertainty. And then we have decision uncertainty. So that is again customer routing. Okay, when customers come in, and we have grocery store environment, you have regular checkout, you have self-serve checkout, and you have express checkout. Which of these checkouts will a customer choose? So there is an uncertainty right there. And whether the customer comes in, okay, in a post office and looks at the line, oh, this line is too big, so I'll come later, and the customer leaves. So barking. So whether the customer will join the queue or not. So that's another source of uncertainty. Okay. Now, how do you simulate all of these different uncertainties? Okay. So again, there are two different ways in which you can model random behavior. We've already seen this very often in at risk. So you can use a discrete probability distribution or continuous probability distribution. So you'll use discrete probability distribution if the uncertainty involves discrete units, integers, if you will. So like order quantity or number of workers absent. So those are uncertain quantities that are whole numbers. So finite number of possible values, then you use discrete distributions. So like number of items in a lot or number of members in a group and things like that. If it is continuous, like time, okay, arrival time, service time, or distance. So how long does it go? How long is the route and things like that. So you use continuous distribution. Yeah. So those are the two kinds of distributions that we will see, and we have already seen some continuous distribution examples in at risk. So the same thing applies here in discrete event simulation as well. Now system variables, okay, what are the variables that you have? So you have decision variables. So these are the variables that we control. So we decide, okay, how many teller windows we're going to have open, or how many machines we're going to have, how long are we going to run the shift for, okay? Things like that. Those are controllable variables we control, and we can run simulations using various different values for these controllable variables, decision variables, and compare the results that the simulation produces. Now, independent variables are the variables that are input variables, like service time, processing time, and event arrival time, and things like that. Those are not in our control. We observe the model, observe the working environment, and then we try to replicate that in the model. So those are independent variables. We cannot control those. We can only observe and replicate it. And response variable is what we observe from the system. Okay, these are the metrics. Okay, how long are the customers having to wait? Okay, how long is what is the utilization of a machine? How many what distance does a worker have to walk in a production layout? So things like that. So there are three kinds of variables: decision variables, independent variables, and the response variable. Response variable is the output variable. And some examples here of the response variables. Okay, flow time, okay, average time for the entity to enter the system to exiting the system. Utilization, percentage of time resources are in productive use. Okay, waiting time, so time spent waiting, obviously. And queue and inventory level. So what is the, if you have waiting lines, what is the average length of the waiting time? What is the maximum number of entities waiting in line over a period of time? Okay, how often is the waiting line empty? Okay, when customers are able to arrive and get service immediately. Okay, and in case of inventories, how long we run out of inventory, how long does what is the rate of stock out, and what is the average stock, and from which we can compute holding cost and things like that. And throughput is the total output. Okay, in a service environment, it will be number of customers served, and in manufacturing, it will be number of parts produced. Okay, so these videos so far we've been discussing in general terms what discrete event simulation is. Contrast that with Monte Carlo, and what are the different elements in discrete event simulation model. What are the variables? Where is the uncertainties are coming from? The kinds of distributions, variables, and the system's performance. Next, we will get into Pro model itself.